in the lecture series of Digital Electronics KOE 039/049, myself Dr. Kishanu Kundu, and this is lecture number 10, and in today's lecture we will be discussing a very big example of combination circuit, that is magnitude comparator. So, let us start today's session. In today's session we will be going to discuss three type of magnitude comparator: 1 bit magnitude comparator, 2 bit magnitude comparator and 3 bit magnitude comparator. So, let us begin. First of all, we will discuss what is comparator. Suppose there are two students, okay, and one student has got 24 in maths and second student have got 25 in maths. So, if one have got 24 and 25, suppose A have got 24 and B is 25. So, we will compare these two numbers. Okay. So, we can see that A has got less than B. So, comparison is done. So, by this concept there will be three cases. One will be, it can be A is equal to B, that is both have got the same numbers, or A less than B means A has got less than numbers from B and A can get greater the number from B. So, these are the three concepts of comparison. This concept will be going to using in comparator circuit. In binary combination also the same concept will be going to use and implement a comparator circuit. So, let us start. First of all, we will discuss 1 bit magnitude comparator. So, a comparator, in the previous slide itself I have told you what is comparator. The comparator is used to compare 2 bits, is called single bit comparator. It consists of 2 inputs for 2 single bit numbers and 3 outputs. Already I have taken, one is A greater than B, one is A is equal to B, one is A less than B. So, let us start. So, first of all we have taken 2 bits A and B. So, 2 variable, how many combination? 4, 0 0 0 1 1 0 and 1 1. So, 0 0 0 1 1 0 and 1 1. This is nothing but decimal 0 1 2 and 3. Okay. So, the first comparison, it can be A less than B, A can be is equal to 0 and A can be greater than B. So, here see, value of A is 0, value of B is 0, means both are same. So, this one, this column, so we will put 1 here, got it, because this condition is satisfied, both are same 0 and 0. Now, A is 0 and B is 1, means A less than B, right, here A less than B. So, here we have put a 1, this column A less than B. Now, A is 1 and B is 0, means the value of A is 1 and value of B is 0, means A greater than B, right. So, here in third column we have put a 1, okay. And the last case 1 1. So, here A is also 1 and B is also 1. So, the equal condition is satisfied. So, here this here in A is equal to B we have put a 1. Is it clear, the truth table to all of you? So, now this thing we are going to implement using K map and we will get the minimized version. Okay. So, there will be 3 K map because 3 output they are there. One output is for A less than B, one is for A is equal to B and one is for A greater than B. Okay. So, first K map we will be drawing for A less than B. Okay. So, 2 variable combination 0 1, this is A and B. So, this will be 0 and 1, this will also be 0 and 1. Okay. So, this is 0 1 2 3. So, you can check here only output is 1 only for decimal 1. So, we will put here 1, got it, the K map concept. Now, I will do the 3 K map simultaneously and we will solve it. Okay. So, this is for A equals to B. So, for A equals to B, again format is 0 1 0 1, the numbering format 0 1 2 and 3. So, for A is equal to B, see we are having 2 places where the output is 1. First one is this this. For decimal 0 we are getting 1 and for decimal 3 we are getting 1. So, A is equal to B can be written as A is equal to B can be written as summation small m 1 0 and 3 0 and 3, got it. So, just put here 0, in 0 and 3 we are putting 1s, clear, and last one is A greater than B. So, A greater than B is only for decimal 2. So, if we put like this A B 0 1 0 1. So, the format is 0 1 2 3 and we are getting output as 1 for decimal 2. So, here only we are having 1, got it. So, now we will make the grouping of ones. So, here no other one is there. So, one single group will be there. Okay. Here also the no adjacent ones. So, two groups will be there and in the third one is one single one. So, one group is there. Okay. So, what will be the value for this? This is nothing but A bar B. This is nothing but A bar B. So, for A less than B we are getting the minimized version is A bar B. This is we are having as for the 3 is this is for y equal, this is output for y less than and this is for y equal. So, we will be getting as A bar B plus A B bar, these two are getting, okay, and for greater than y greater. So, for y greater we will be having A B bar. So, 3 condition you have satisfied. For less than we are getting minimized expression as A bar B, for equal we are keeping A bar B plus A B bar, and for greater than we are getting this equation y greater is equal to A B bar. Okay. 3 conditions we have already got. So, now this is the design of the magnitude 1 bit magnitude comparator. Already we have drawn the example, the expression, 3 expression we have got, one for less than, one is for equal and one is for greater than. So, now we are going to design it and this is the final design. You can check it out. This is for y less than, this is for y equal and this is for y greater. 3 conditions already we have written the K map Boolean function, we have already done it and we are implementing using the logic gates. Okay. So, this is the magnitude comparator circuit. So, next let us go for 2 bit magnitude comparator. Till now we are just comparing 1 bit 0 and 0 or 0 and 1 or 1 or 0 or 1 or 1, only 2 bit comparison, only 1 bit comparison is there. Here we are going to compare 2 bits. So, a comparator used to compare 2 binary numbers, each of 2 bits is called a 2 bit magnitude comparator. Like that, suppose one combination here A and B. So, A is 0 0 and B is 0 1. So, now this A is total 0 0 and B is total 0 1. So, now we will compare these two. So, see A is 0 0 and B is 0 1 means A less than B, right, because 0 is decimal is 0 and 0 1 decimal is 1. So, 0 is less than 1. So, we are having A less than B. This concept is going to we are going to use and this we will implement the truth table for 2 bit magnitude comparator. Okay. So, let us check the definition of 2 bit magnitude comparator. A comparator used to compare 2 binary numbers, each of 2 bits is called a 2 bit magnitude comparator. It consists of 4 inputs and 3 outputs. 4 inputs means A1 A0, see this is for A. So, this is nothing but A1, this is nothing but A0 and this is B1 B0, when B is represented as B1 and B0. So, total 4 inputs are there and comparison output will be 3 outputs. Again the same type of comparison will be there, A can be less than B, A can be equal to B, A can be greater than B, 3 cases. So, here this is A less than B, this is A is equal to B and this is A greater than B. 3 combinations will be there. So, now let us check the truth table. So, very important, see now you can see the grouping will be 2 bits, this is 0 0 and this is also 0 0. So, A is also 0 0 and B is also 0 0. So, both are equal. So, here we will put 1 for this column, A is equal to B. Okay. Now, next A1 A0 is 0 0 and B1 is 0 1. So, now you can see this is nothing but 0 in decimal and this is nothing but 1 in decimal. So, A is less than B. So, here we are putting 1 in this column, A less than B. Like that, suppose this is 0 0 and this is 1 0. Again 0 0 is nothing but 0 in decimal and 1 0 is nothing but 2 in decimal. So, 0 is less than 2. So, means A is less than B. So, here we will putting as 1. Okay. Like that, this is 0 0 and this is 1 1. This is nothing but decimal 3 1 1 and this is nothing but 0. So, 0 is less than 3. So, we are having A less than B. Got it? Okay. Next, this is 0 1 and this is 0 0. So, now 0 1 means decimal 1 and 0 0 means decimal 0. So, in this case A is greater than B. So, we will put 1 in this column. Okay. Similarly, for 0 1 we are having this is also 0 1. So, A is also 0 1 and B is also 0 1. So, both are equal. So, we are putting as 1 in this, A is equal to B. And how to write this combination? So, you can just simply you can write from 0 to 15. This combination, this 4 variables, already we are having 4 inputs. So, 4 variables. So, how many combinations? Total 16 combination, 2 to the 4 means 16 combinations. So, this input part you can write that from 0 0 0 0 to 1 1 1 1. Okay. This you can write, and by this is I have already told how to check, how to compare both the three. Again we can check this number, this is 1 0 and this is 0 0. So, 1 0 is nothing but 2 in decimal and this is 0. So, you can clearly say that 2 is greater than 0 means A is greater than 0. So, the last column will be 1. Okay. Clear? So, like that we will solve the full truth table, and after truth table we are getting 3, we will be forming 3 K map. One is for A less than B, one is for A is equal to B and one is for A greater than B. So, let us start. So, the design is for first of all we will design for A greater than B, this one. So, A greater than B, if you check this table we can find that y greater than is having the min terms as y greater will be for min terms, you can write 4 8 9 4 8 9 12 13 14 12 13 14. For this combination we are getting output as 1, and this is for y equal means the middle column y equal this one. So, here for which combination we are getting 1. So, y equal be summation small m 0 5 0 5 10 and 15 10 and 15. You can check it from the truth table itself. We are getting here as 1. So, this is 0, this is nothing but 0, you are having this is 1. So, this is 5, this is another one, this is 10 and another one is for 15. So, only 4 ones we are having. Okay. So, now let us do the K map. Okay. So, this is 4 variable A1 A0 and B1 B0, the combination is 0 0 0 1 1 1 1 0, again here also 0 0 0 1 1 1 1 0. Okay. So, just we have put the values. So, this is nothing but 0 1 3 2 4 5 7 6 8 9 11 10 12 13 15 14. So, now using the number format we are putting the values. So, here in 4 we are having 1 1, in 8 we are having 1 1, for 9 we are having 1, for 12 we are having 1, for 13 and for 14. Okay. K map is clear to you. Now, we will do the grouping. So, there are 3 groups will be coming. See, one is for this one, these two ones will be grouped together. So, what will be the value of this grouping? This will be nothing but A1 A0 A1 A0 B0 bar, A1 A0 B0 bar. So, here one quad also are getting. So, this quad will be having as value as A1 B1 bar. Okay. And here again these two will be grouped together. So, it will be values as A0 B1 bar B0 bar. Take it, how it is coming? See, this is nothing but 0 1 and this is 0 0, means A1 bar A0 B1 bar B0 bar, and this is nothing but 1 1 0 0 1 1 0 0, means A1 A0 A0 B1 bar B0 bar. So, what is common in the case? See, these two we are having A0 B1 bar B0 bar. Okay, clear? So, ultimately we are having the equation for this. So, Yg will be written as you can write down A1 B1 bar A1 B1 bar plus A1 A0 B0 bar plus A0 B1 bar B0 bar. Okay. This is the final expression for y greater. Okay. Now, we will do the third one, the second one, this is for y equals to. So, see here no grouping is possible, all are individual, 1 this 4, no adjacent ones are there. So, we will write the equation for y equals to is equal to A1 bar A0 bar B1 bar B0 bar. So, this is nothing but this one is A1 bar A0 bar B1 bar B0 bar. Okay. Now, this next is A1 bar A0 B1 bar B0, A1 bar A0 B1 bar B0. So, this is nothing but this one. Okay. This one will be A1 A0 B1 B0, A1 A0 B1 B0. Okay. And this last one, this is nothing but to write down A1 A0 bar B1 B1 B0 bar. Okay. So, here this is for y greater and this equation for y is equal to. Okay. Got it? Now, what is left? Y less than. Okay. The first column is left. So, for y less than we will write. So, y less than the mean terms will be like that, summation m will be 1 2 3 6 7 11 6 7 and 11. So, for as the format 1 2 3 1 0 1 3 2 4 5 7 6 8 9 11 10 12 13 15 14. Okay. So, now we are putting the 1. So, for 1 here we have written as 1 1, for 2 we have written 1, for 3 we are having 1, for 6 we are having 1, for 7 we are having 1, for 11 we are having 1. So, now the ones have been placed, now we will do the grouping. So, first grouping will be between these two. Okay. First grouping will be between these two. So, this is nothing but A0 bar B1 B0, A0 bar B1 B0. Okay. When getting one quad also, this is quad is nothing but A1 bar B1, A1 bar B1, and this two combination will be as write down A1 bar, A naught bar, A1 bar, A naught bar and B naught. Okay. So, we can write down as y L is equal to A1 bar B1 plus A naught bar B1 B naught plus A1 bar A naught bar B naught. Okay. So, we have written 3 combination for y greater than, y equals to, y less than. So, this will be the ultimate equation, already I have told you. So, this is for A greater than B. So, the answer will be this one for A equals to B. So, already you have written this format, you can see already you have written this one, okay, this expression. So, now we can minimize, solve that, you can minimize this and it will be as A naught x naught B naught and A 1 x naught B 1. So, it will be nothing but like this, A naught x naught B naught and A 1 x naught B 1, okay, like this. This is a minimized format, nothing else. This is A less than B. So, already I have written the expression. So, these are the 3 expression for A greater than B, A is equal to B and A less than B. So, now this is the final design of 2-bit magnitude comparator. Whatever we have designed the equation, just using the logic gates we have implemented it. Okay. So, this is that the x naught I have already told. So, this is the minimized format, this is the minimized format. So, for that only we have done like this. Okay. So, this is 2-bit magnitude comparator, I think you have understood. And the last topic of today's session is 3-bit magnitude comparator. So, till now we have compared 1-bit, 2-bit and 3-bit is the most advanced one. So, in it is a comparator which compare 2 binary numbers having 3 bits and produce the resultant of 3 outputs on the basis of magnitude of given binary numbers is called 3-bit magnitude comparator. This is more effective than a 2-bit magnitude comparator. Obviously, the equations, so see like that I can give a small example. Suppose now here A and B. So, A will be represented as A2, A1, A0 3-bit pattern and B will be represented as B2, B1, B0 pattern. Okay. So, this is the pattern. So, suppose I am having 2 decimal digits, one is 786 and this second one is 785. So, I have to compare this. So, first of all we will do the comparison of the most significant digit, this is first of all we will check this. So, if these 2 are same, then we will go for the second most significant digit. So, now here these 2 are also same, then we are going to compare the third one. So, the comparison is doing like this, first we have to compare the 4 most significant digits, then we will compare the next and like that it goes on. Okay. So, with this concept we will do the same thing in the binary operation itself. So, binary itself also when we are comparing, so comparison is doing that A2 A1 A0 and B2 B1. So, first we will compare A2 with B2, then if both are same, then we will go for the next one, then we will compare A1 with B1 and if then again also they are same, then we will go for A0 and B0 and if it start at the starting itself A2 is greater than B2, then the number is A is greater than B. If A2 is less than B2, then obviously A is less than B. So, we will check from the most significant B. So, like that. So, if A0 is B0, then we will do the following expression. So, we will get the, after doing all the K maps, we will got the this answer A0 bar B0 bar plus A0 B0 plus A1 bar B1 bar plus A1 B1, A2 bar B2 bar plus A2 B2. So, now if the second condition A less than B, so we will check A2 is less than B2, problem solved, is A2 is B2 is equal to B2, then we will for A1 B1 and if A2 is equal to B2, A1 is equal to B1, then we will go for the third condition, already I have discussed you. Okay. So, for that we will getting the formula for this, you can check the formula here it is if it is not visible up to this, I think it is visible A 2 B 2 A 1 B 1, again it is written like that A 1 bar B 1 bar plus A 1 B 1 A naught B naught A naught bar B naught. Okay. What is not visible, I have written here. Okay. And next the last is A greater than B. So, we will check if A 2 and B 2, the problem is solved. We can check that A is greater than B, but if A 2 is equal to B 2, then we have go for the next checking A 1 and B 1, and if it is visible that A 1 is greater than B 1. So, you can conclude that A greater than B, but if A 2 is equal to B 2, A 1 is equal to B 1, then we have to go for the third one. So, it will be A naught greater, if it is A naught is greater than B naught, we can check that A is greater than B. So, the final answer for A greater than B is like this after doing the K map solutions. So, now and this is the final circuit diagram of 3-bit magnitude comparator. Whatever Boolean expression we have got for y is equal to, this is nothing but y equals, this is nothing for y less, and this is nothing but y greater. 3 output already we have discussed in 2-bit magnitude computer. So, this we can implement using the basic logic gates. So, this is the final design for 3-bit magnitude comparator. So, this is the complete lecture of comparator circuit.